Alright, let's go over this lesson over rational expressions that wasn't able to be caught earlier. So let's go again and jump right in. Okay, notice whenever we're dealing with rational expressions, if we start thinking about them in the same way that we start thinking about fractions, it's going to be helpful to do that a whole lot, because a lot of the rules that we deal with rational expressions are going to be the same thing that we deal with when dealing with fractions. Okay, so we kind of remember those rules. It's going to help out a whole lot. So let's kind of scroll down here and kind of see what we're talking about. Notice a rational expression is an expression that can be written as a ratio of two polynomials. Okay, we learned about what those are, of p over q. Such a fraction is undefined for any value or values of variables for which q cannot equal 0, because that would make it undefined. Okay, a given rational expression is simplified or reduced when p and q have no common factors other than 1 or negative 1. So let's kind of look at this first one here, and then we'll kind of go through it. So notice rule number 1, okay, I'll kind of write over here, is always go ahead and factor first. Okay, so let's just write that out. We're going to factor. So let's come in here and notice on this first one here, we've got a special case scenario of a difference of cubes, which this is going to be of the form a cubed minus b cubed, which is also, we could have the formula for that of a minus b, okay, and then also a squared plus a b plus b squared. Okay, so factoring that one even further, go ahead and label this, got a and I have b. We can say that, okay, for a, let me write that out a little bit better, the cube root of x cubed is going to be x, and then for b, the cube root of 8 will just be 2. And now we have enough information here to put this straight into our formula. Well, we can say that the a minus b is going to be x minus 2. And then we know that the a squared is just going to turn into x squared. And then we have a times b. We're going to put our plus symbol here. That's just going to turn into 2x. And then we go ahead and square the 2, and that's going to give us a 4. Okay? Well, we notice that is now our numerator. Okay, well now we need to come over here, and we'll go ahead and just come down this direction, and let's go ahead and factor this guy. And then notice we have x squared minus 2x. Well, this one is not a special case, but we can go ahead and factor out a GCF, which is going to turn this into x. Okay, and then that's going to turn that into x minus 2, just for clarification. Remember, whenever you're factoring out, it's reverse distribution. Come in here and just divide out the x. Okay, so notice here that x is going to leave it just with 1 on top, and then these over here are going to reduce. There we go. So notice now we can rewrite this as x minus 2 and x squared plus 2x plus 4 all over this x minus 2. Now if we were solving, it would be now that we start looking for restrictions. Remember, restrictions are whatever is going to end up making this 0. So if we kind of come over here, we say x cannot equal 0 and 2. Well, how do I know that? Because notice if we were solving this, x cannot equal 0, and then x minus 2 cannot equal 0, and then we just solve accordingly. Okay, but remember, okay, restrictions come before simplification. Okay, but for this case we didn't have to worry about that. So in this case we're just going to come in here and go ahead and reduce this out like so, and then our final answer here would be x squared plus 2x plus 4 all over x, and that would be our final solution for this example. Well, let's go ahead and try another one. Well, here we have another one of x plus 1 over x plus 3 and so on. But remember, our first rule here is we're going to want to go ahead and factor everything. Okay, so we'll go ahead and start with our factoring process. So we're going to say 1, we're going to factor. Okay, and we'll go through here, and I'm going to go ahead and do this factoring pretty quick because we're just going to be using the AC method, which you can kind of look up on how to do. But I do know that this top one here is going to factor into x plus 2 and x minus 1. Okay, this bottom one here, I can go and scratch that out. This one here, notice I can come in here, go ahead and put my parentheses down, go ahead and put my x's in both. I know that I'm going to have opposite signs because of that negative constant, and then I know my larger number is always going to be negative, so notice this is going to be a 3 and a 2. 2 minus 3 does give me the negative 1, and then the multiplication works as well. Well, notice here that this one here is not factorable, but we're not solving, so we're only going to worry about the factoring process right now. So since this guy doesn't factor, we leave it alone. But notice this guy here is a special case. This is a difference of squares, which is of course a squared minus b squared, which is equal to a plus b, a minus b. So we know that this guy is going to factor into x plus 3 and x minus 3. For this case, we're going to go ahead and rewrite everything. That needs to become something we really kind of get used to doing, and so we're going to go x plus 1 all over x plus 3 plus x plus 2, x minus 1. Rewrite the bottom, x plus 2, x minus 3 minus x squared minus 2x plus 9. All over the x plus 3 and then x minus 3. Now if I were going to be solving this, it would be now that I would be looking for restrictions, but since I am not going to be solving, I can go ahead and do some reducing out, which is, notice that this right here will now go away. Okay, so that reduces out. It does not cancel, it reduces. So since that reduced out, we can go ahead and realize that we can rewrite this one more time, which is going to give us, okay, x plus 1. And notice when I do this, I'm going to be leaving myself a little bit of room here. Then I got a plus x minus 1 all over x minus 3. Leave myself a little bit of room. And then once again, I got x squared minus 2x plus 9 all over the same denominator. Well, notice what I just said. We're now going to need to find a common denominator, which means we need to just start multiplying everything to make sure all these denominators match, which is exactly what we would be doing if we were dealing with fractions. So notice this has an x minus 3, but it doesn't have the x plus 3. So let's go ahead and give it the x plus 3. And then we're going to do the same thing here. This has the x plus 3, but let's give it the x minus 3. Okay, and then now notice, since we have a common denominator all the way across, we can go ahead and rewrite this thing, and I'm going to kind of come up here so I give myself a little bit of room. And so I end up having x plus 1, x minus 3, plus x minus 1, x plus 3. Then I have a minus here. We've got to be careful with that minus here in just a little bit, okay? Because I want to go and put this parenthesis down, because I'm going to have x squared minus 2x plus 9. Because I know here in a little bit, I'm going to want to take this negative and distribute it into here, okay? And then let's go ahead and just draw our huge denominator line, or our huge fraction line there, and realize that now we can just kind of combine everything here up to x plus 3, x minus 3. I'm going to do the foiling process. I'm going to pause this and kind of just show you what this is going to look like. So here I have everything all foiled out. So let's kind of come here and start working this out and realize that I can go ahead and start kind of simplifying this now. So notice I've got an x squared here, but I've also got a negative x squared. So I know this guy right here is going to go away. And that's going to just leave me with this 1x squared here. So we'll go ahead and just write that down. And then I've got this negative 2x, and then I've got a positive 2x. So notice that is also going to go away. Okay, and so that's going to leave us with a plus 2x. Sorry, I had a little bit of pen trouble there. So notice we're going to be left with the plus 2x in here. So we're going to write that down right there, plus 2x. Let's go ahead and reduce that out. Make sure you always scratch everything out. Don't scribble out, please. Okay, try not to do that. And then notice here we have negative 3, negative 3, negative 9. That's going to give us a negative 15. And then we can go ahead and come in here and once again put our x plus 3 and then our x minus 3. Well, one more round of factoring, and then we can have this thing set all kind of tightened up and done. Okay, so let's come in here and just kind of come over here and notice this is going to factor into x Let's go and put our two parentheses down, and we're going to end up having x plus 5, x minus 3. Oops, sorry, having a little bit of pen trouble here. X minus 3, all over the same thing, x plus 3, x minus 3. I apologize for the pen trouble. And then notice here, these reduce out, and then we are going to be left with x plus 5 and x plus 3 as our final answer. Okay, so we can kind of continue on. So continuing on here, we can kind of look over one more little example here that I've got right here, and then that will kind of be how we're going to keep doing these simplifying complex rational expressions. So for this one, obviously we're going to go ahead and want to find an LCD again, just like we did prior. Okay, so let's kind of come in here and notice that we do have an LCD here of x and then x plus h. Okay, I apologize for that little blue part there. And let's go ahead and multiply everything by that. So notice I'm going to come in here very carefully again, and even in the bottom part I'm going to go ahead and add this. Okay, I'm going to add x plus h, x plus h, x plus h. Okay, and then I'll go ahead and reduce out, and notice here the x plus h goes away, reduces out. Here the x reduces out, and then here nothing reduces out here. Okay, we can go and kind of get rid of this because I don't want it to be confusing. Okay, and then let's go ahead and make sure that we rewrite. So notice what we're going to have here is x minus parenthesis x plus h all over. Well, what do we have here? We don't have anything left here. So notice for the bottom here, we're just going to be left with this x plus h. Okay, but we need to realize that this guy right here is now over 1. Okay, do you see how that kind of works out? So notice here, I can go ahead and start doing the math here. Let's kind of figure this out here just a little bit there. So let's go ahead and drop this and realize that we've got x, okay, once again, minus x, and then plus h. And then we can come over here and notice I've got this x plus h. Well, notice this x minus x, well, that's just, these are going to reduce out completely. Okay, and then I do apologize. That right here, this plus symbol, remember we put that in there, and so that should be a negative now. So when we start the rewriting process, notice we're going to have negative h all over x plus h again, and then notice also again this h will reduce out, and that is going to leave us with our final answer of negative 1 all over x plus h. It is worth noting that if you look in your notes, I did this a little bit a different way. I did it to where I basically found common denominators here, add them together, and then did the division. But this is a very much quicker and very much easier way. So let's do one more, and then this lesson will be done. Notice here, a very simple one here. You've seen something like this before, but we have negative exponents. Well, realize when you have negative exponents, let's make this very simple. When you have something of the form a to the negative n, that will turn into 1 over a to the n. And the opposite is true. Okay, if you had 1 over a to the negative n, that would just turn into a to the n. Okay, so having said that, let's come in here and rewrite this in the way it should be written, and that's going to be 1 over x minus 1 over y, put our big long fraction bar, 1 over x squared minus 1 over y squared. Now realize we need to find our LCD. Our LCD is going to be the largest power, okay, and that's going to be x squared and y squared. And so let's go ahead and get rid of these fractions. Okay, just like what we would always done, x squared, y squared, x squared, y squared, x squared, y squared, and so on and so forth. And then we can start reducing. Notice this x goes away, leaving only 1 up here. This y goes away, leaving only 1 up here. This x squared reduces that one, this y squared reduces that one, and then we can go ahead and kind of clean this up. Let's go this way with it. I'll kind of work down just a little bit. Notice I'm going to end up having xy squared minus x squared y all over y squared minus x squared. And to be honest, that's pretty much where I would leave it. You could always come in here and factor out an x and a y on the top, but there is really no reason for it. Okay, so there you go, and hope that helps out.